fly like you stole it.
And welcome back to the fourth video in this playlist. So what I'm going to cover today is the work that I've done and some continuity checks and a quick test in betaflight before I move the build on. So this morning some new heat shrink arrived, some smaller stuff. The stuff I had before was just too big, so I waited for the small stuff to arrive, and then I carried on. I soldered the ESCs to the FC and then done some continuity checks, and that's where this video is going to come into. So I'm going to move across to the board itself. So here you can see on the frame, ESCs are now heat shrinked. They actually are double heat shrinked. So the ESC is heat shrinked once, then there is some M3 tape holding the ESC to the arm, and then heat shrinked over the top again to keep it all down. So no use of electrical tape or zip ties. All looks nice and good. The only problem is that when it comes to maintenance, if I have to strip it down, I'm going to have to cut all that heat shrink off and then put it all back on again. Bit of a nose, but I've only have to work on ESC when I've cooked one, so hopefully not very often. So back to the frame itself. So as you can see now, everything's connected up. I have the positive for the ESC on one side, negative to the ESC on the other side, and then I have the ground for the ESC, the telemetry pad, and the signal pad. All the wires match. Now, if I was to do this again, I'd probably go from solder everything to the ESC, the FC first, then to the ESC. Gives me a bit more room to work on. But in this instance, I went from ESC to FC, and it made getting these in here a little bit difficult. They are the side cut ones, and it took a couple of attempts to actually get it in. My soldering isn't the best, so some of the wires, one wire is just a little short, and some of them were a little bit tight to get in, but they're in, they're secure, and they're not actually going to go anywhere, so I'm happy to actually proceed with this build. So once you've got everything connected in, the next step is to plug it in and to actually see what happens, make sure it all works. But before you plug it in, I always do continuity checks. So I get my continuity meter, check over my points just to make sure there are no shorts, because the last thing you want to do is spend all that time soldering it, putting it all together, all the heat shrink, and then you plug in your battery and then you let the white smoke go, and then it's game over and you have to start again. So I'll just turn this on, make sure my meter actually works. Alright, first check then, straight across the XT60 terminal, and wait for a turn. There. See, there's a short beep and then it stopped. The short beep is the capacitors on the flight controller and ESCs just discharging, and once they're discharged, that's it for the beep for there. So the fact there's no beep is a good sign. It looks like so far I got everything all the way around, but I'll carry on checking now just to make sure. So I'll hold one end into the negative terminal on the XT60. Make sure it's in there. And then check some of the ground, the negative points on the board itself. So FC itself, and then work my way around, and they're all good. The ESCs have a negative terminal on as well. They're good as well. And then check some positive pads to make sure there's no continuity there. So it's none on the main XT60. Working around some of the ESCs. Nope, nothing. No shorts, no continuity. So that's all really good at the moment. Now, checking the main XT60 and the ESCs doesn't check the motor wires and their telemetry wires on the ESC itself. So I go around, because they're quite close together, I touch the wires next to each other and then work my way around to make sure there's no continuity between them when there shouldn't be. So we'll start this one here. So we go for the signal and telemetry wire. Nothing there. Telemetry wire and the ground wire. Nothing there, good. So they're not touching at all, because they are actually quite close together. You just want to make sure. Yeah, all the way around. all the way on. Yeah, so I'm happy. No continuity where it shouldn't be. Right, so the next step then is to plug in the Lipo, but I also have a smoke stopper, which is very useful to have. It's just a 12-volt car bulb, two XT60s. The ground is linked together as a loop, and then the positives actually run through the bulb itself. One end goes to the terminal at the bottom, one end goes to the side of the bulb. The idea is that if you have a short, the bulb lights up and doesn't smoke your flight controller. It stops too much current going from your Lipo into your flight controller, and helps with testing. This would have saved me once before when I set an ESC on fire in the evening. I fit the new ESC, but I actually reversed the pos and neg leads. Continuity checks worked out fine because I was actually moving the probes around. I didn't realise that when I was getting the wrong result, I was switching the probes over to get the right result. It wasn't what I was supposed to be doing. And when I plugged in the Lipo, I instantly smoked a brand new ESC. So then I had to order a new one and wait for that. So I was out the air for longer than I should have been. So we'll plug this in. One end into the quad itself, and the other end into the Lipo. There. FC is lit up. Now this is an all-in-one board, so if it's got power, it should light up. If you had a PDB and it lights up, your Lipo is powering the PDB, which is then transferring the power up to the FC, and that's then working as well. So I'm happy that that works. So what I need to do now is grab a USB cable and just plug into Betaflight and then test to make sure that it is actually working. Right, when plugging in the USB cable, don't place your thumb across the two terminals. That may sting. So I just switch transitions on OBS and have a look at Betaflight. So click connect. Good, board's running. Up top here, you can see that I am showing voltage from the Lipo, so that's a good sign. Go across to configurator. Notice that ESCs are brushed. That's why I didn't get a final tone when they booted up. So I'm going to swap that to D-Shot 600 and just leave everything else as default at the moment and click save and reboot. And that sounds much better. Right, so if I go to the motor tab now, right, disconnect. Now my Betaflight has decided to have an issue. Sorry, I bet that slurping was loud. Right, close Betaflight. There we go. Right, reconnect. There we go. Right, motors tab again. Right, so what I'm going to do is I'm going to tick the I understand the risks. I'm going to arm the props, arm the motors. If you have props on now, this would be a really bad thing to do. Get your props off. So give it a tick. Raise the master slider very slowly. And that's all four motors spinning. So that's good. All four motors are receiving the ESC signal from the flight controller, throttle signal from the flight controller, and all the motors are actually responding to that. So I'm happy that everything seems to be wired up correctly. So I'm going to untick the box, go back to configurator. Yeah, so one of the other videos I do will be setting up Betaflight so that the gyro is set, all the ports, tabs, everything else is set up correctly, but that's a later on video. Next up, what I'm going to do is I'm going to stop this video and I'm going to carry on soldering the rest of the hardware on. So I'm going to get the GPS on, the RunCam on, the TBS Unify and the TBS Nano, and get them all wired up, and then the continuity check again, and then come back for a video with Betaflight on how I'm going to configure this and see if it all works, because I'm still unsure whether some of the UARTs are going to do what I need them to do. So for now, that's in this video. I'm off to do some more work. Thank you for watching.